Hello friends, welcome back to Coding Interviews channel. Hope you are doing great. If you haven't subscribed to the channel yet, please go ahead and subscribe. I have created a bunch of playlists to cover various categories of problems such as dynamic programming, BFS, DFS, and also some playlists to deal with all the basic data structures such as stacks, queues, linked lists, trees, graphs, and so on. Please check them out. I have uploaded the code for this problem to the GitHub repository. You can get the link from description of this video. Let's jump into today's problem. Insert, delete, get random, order of 1, duplicates allowed. So design a data structure that supports all following operations in average order of 1 time. So there is a note given, duplicate elements are allowed. So we are asked to design a data structure that supports 3 operations. What are those 3 operations? Insert, remove, and get random. So these are the 3 operations that we need to support in order of 1 time, right? So insert of val, this is going to insert an item to the collection. Remove, it's going to remove an item from the collection if it is present. And get random, return a random element from the current collection of elements. The probability of each element being returned is linearly related to the number of same value in the collection contains, right? So basically we have to design these 3 operations, and one thing that is mentioned here is the duplicates are allowed. So on the Leetcode there is another problem which is 380. This problem is 381, and there is another problem which I have already uploaded the video for this 380. Insert, delete, get random, order of 1, right? So in order to better understand this problem, what I am going to show you in this video, please watch the problem 380. I have put the video for that particular problem in the description section. So please pause this video right now and watch the video for 380, because whatever the concept that I explained in the 380, that is the same concept I am going to use here. It's a little bit extension of whatever the concept that was there in the problem 380. So please watch video number 380. You can get the link from the description from this video, right? So but just to recap, we are going to use a hash table data structure for this particular problem also. So as we know, hash table will have a order of 1 insert and removal, right? So if we use a hash table, we will be able to get the order of 1 for insertion and removal. But there is another operation called get random that also need to be supported for this data structure that we are going to build, right? So but hash table on its own cannot give you the random value in order of 1. So that means just by using hash table it's not going to be enough. So we need to use something else, right? Just like we did the same thing as part of the problem number 380, right? So please watch that video also. So there is a strong correlation between the 380 and 381. That's the reason why I'm asking you to watch 380 prior to watching 381, right? So in this particular case, duplicates are allowed. That means whatever the element that is there in hash table, people could insert multiple times, right? But normally in a given hash table, right, if you were to put the same value in the hash table again, right, there will be a hash collision, right? So for that purpose we need to devise a betterment of that particular algorithm, right? So here what we are going to use is, instead of keeping the numbers themselves, right, we are going to keep the order in which they got inserted, right? So we are going to keep the order in which they got inserted. So the order starts from 0, okay? So just like the order starts from 0. Imagine we were storing these elements in a list or an array. So list or an array, the index starts with 0, right? So that's why I'm saying, okay, as and when the hash table is empty, the first element will be at 0th location. So we will not store the element in the hash table itself, but we are going to store elements and their corresponding locations, or the insertion order for that matter. So insertion order we are going to put into the list. Okay, so that means we will be using a hash table and a list, right? So there are two data structures that we are going to use for this particular problem. There is a hash table and a list, right? So just like let's look at an example how we are going to store it, right? So if this is a sequence, right? So randomized collection, we are inserting 1, 2, 3, 4, 5, right? So there are 5 inserts happening, right? So the first element is 4, second element is 3, 4, 2, 4, right? So what we are saying is we will create a hash table and put the element and their corresponding insertion order, we said, right? Insertion order. So that insertion order is similar to as if we are inserting them into a list. Suppose if we were inserting into a list, right? It is a list's index, the index of that particular element, right? So for this sequence of operation, right, our map is going to look like this, right? So 4, that is the first element that we are trying to insert. And what will be the order of the insertion? Since the map is empty and list is also empty, it is at 0. So we will insert into a list at 0th position and put 0 in here, right? And 3 is getting inserted at 1 into the list, right? 1. So 3 and a 1, right? And 4. So 4 is already there in the map and correspondingly there is a 0. But we are going to insert 4 into 0, 1 and 2, that is second position. It's not exactly third position, but 2 is the index. So put 2 here. And next element to be inserted is 2. At what position? 3, index 3. So 2, index 3. And again last element is again 4 we are inserting. That is at 4th position, right? So we will put 4. So our map will have two things. Map will have two things. What is that? Element and indices, right? Where they are occurring, or you can say the order in which you are putting into those elements, right? Right. So now we have started the list at 0 and ended at 4, right? When we are saying we start with 0 and end with 4, that means we have 5 elements in the list, right? So we are able to insert into the map with order of 1 now, right? But what if we are trying to remove, right? So if we remove, we could easily remove from the map. That's not a problem. We just remove the index 0. If we are to remove, like say number 4, right? So if we are asked to remove 4, so we can easily remove from the map, right? Easily remove from map, right? In order of 1. But can we remove in the order of 1 from the list? Not really, right? Because anything that we want to remove from the list is a order of n operation. So list removal is order of n operations. So this is all what we discussed already in the problem 380, the video 380, right? So it's the same thing that we are trying to expand, right? So but the removal cannot be done in the order of 1 operation. So for that, what we are going to do is, instead of removing, we are going to ignore that particular element. So that element will be there in our list, but we are going to ignore. How can we do that? The element is there in the list, but we are saying we have to ignore that. That means we are going to adjust the start and end pointers, right? So we are going to adjust the start and end pointers. So after inserting all the elements, we are saying the start is at 0 and end is at 1. Now we are saying remove 4. So remove 4. Which 4 we want to remove? Is this 4 or this 4 or this 4? We don't know, right? First of all, we need to go through the list to find out 4 and then remove, right? So for that sake, what we are going to do is, instead of removing the list element from the list, we are going to adjust this start and end, right? So let's go look how we are going to do, right? So we are saying remove 4, right? Get one of the indexes from here. We can get either 0 or 2 or 4. Let's say we are going to get 0, right? So that means we want to remove this element from the list. So that is at the 0th position. If we remove that, right, as we said, it will be order of n operation. We are going to swap that with the last element. So in this particular case, 4 and 4, those are the last elements. And once we swap it, what we are going to do? We are going to adjust this L end to 3, right? So remove of 4, what we are going to do is, start will be 0 and end will be 3. So we swap, right? That is the operation that we do with this, with the last element, and we mark end is 3. So even though there are 5 elements in the list, but the start and end are pointing to 0 and 3. That means what we are doing here, we are just pretending we have only 4 elements, right? So this is what the concept that we are going to use in order to solve this particular problem for removal. So with that, we can say, okay, remove can be done in order of 1 operation. What we are doing essentially here, we will remove from the map. We don't have problem to remove from the map in order of 1, but to remove from the list, there is a problem. So instead of hard removing from the list, what I am going to call this as a soft removal. It's not a hard removal. So hard removal is we are knocking that element from the list, but it is a soft removal. Soft removal is we are trying to swap with a last element in the list and swapping the location. That's it, right? We are going to swap the location. So let's go check one more example. We removed 4. In this particular case, 4 and 4 are the same location, right? That's why they are same. So now what we are going to do is, we will consider a different example and try to work it out, right? So our example is 10, 20, 30, 40. This is our example, and we have a start is 0 and end is 3. So just wanted to remind, we have moved to another example, 10, 20, 30, 40, and start is pointing to 0 and end is pointing to 3. So now we are saying remove 20. So 20 is the second element in the list. What we are essentially going to do is swap it with the last element. So we swapped with the last element. So the list became 10, 40, 30, 20, and our end is pointing to 2, right? That's what we did. So what if we do 10, removal of 10? So our end is pointing to 2, right? So we put the 10 into the 2 position, and whatever it is there in the 2, we put back into the element where we want to remove. So that's what we did. So now start is 0, end is 1. So from here we still see there are 4 elements, but what is our start and what is our end pointing to? Start is pointing to 0 and end is pointing to 1. So that means we just have only 2 elements in the array. So apart from removing the elements from the list, we need to update the map as well, right? That's what we need to keep in mind. So if we just keep on adjusting the pointers or the locations of the elements in list, it's not going to be sufficient. We need to update the locations in the map also, right? So now here 10, 20, 30, 40, right? 10 is at 0th location, 20 at 1, 30 at 2, 40 at 3, right? So now we say remove 20. After removing 20, 40 came into location 2, right? 20 came to location 4, right? So we need to adjust those pointers or the indices in the map as well. So that is what we are going to do. So random will be just selecting a random from this list between start and end. That's it. So that can be done in the order of 1 as well. So that is the concept that we are going to use in order to solve the 3 methods in the order of 1 time with duplicates, right? So the change between the problem without duplicates to the duplicates is we are keeping track of the order or the location index of that particular element in the list, right? So that's the logic we are going to use. So let's go ahead and look at the code for each of these methods: insert, removal and get random. So we have looked the insert operation individually and removal operation individually, right? So now let's say after removing 20, if we are saying insert 60, right? So where should we insert? Where should we insert, right? So it was like this, right? So where the 60 should go? The end pointer is at 2, right? At here, end is at here, but the list length is 4. What we will do is we will replace this 20 to 60, right? So this is what we are going to use. And after inserting 60, we will need to increment our end pointer 3, right? Because now after inserting 60, we have 4 elements. We are back to 4 elements, right? So this is the when there are insertions and removals are happening as part of our process, this is the logic that we are going to use. As and when our end pointer is pointing to the last location, we will add the elements to the list. If it is not pointing to the last element, right, we will replace the subsequent elements. So even this insertion is also order of 1, right? So this is another thing that we need to keep in mind. Let's go ahead and look at all the 3 things. So as we said, a map, the map will have a element and corresponding what are they? Indices, for which I am creating a hash set. Okay, all the hash set will have indices, and then this is a list that I am creating, and we have 2 things, a start and end pointers, right? Basically they are indices, and then there is a random class initialization. So I am going to initialize them as part of our constructor, right? So start will be pointing to 0 and end will be pointing to -1 to start with. Okay, now let's go ahead and look at each of these operations. First we will look at insert, removal and get random. Get random is a pretty simple one, since we are doing the heavy lifting as part of the insertion and removal, right? So now insert, first we are going to check where is our end pointing to, right? So if the list length is equal to the end, right, the number of elements is same as the end pointer, then we just append. We don't have to do anything, we just append and increment the end pointer. But otherwise, the otherwise case is when we removed some things and inserted into those places. This is the case, this is the else case. In that particular case, what we are doing is we are incrementing the end pointer and putting that value into the end pointer. So this is what we are doing. Just like in place of 20, we put the 60. What we did, update the end pointer 2 to 3. That's what we are doing here, right? And if the element is already present in that map, that means, so here in the particular first example, right, we have been inserting 4s 3 times. So in this particular case, what we are going to do is we keep on adding the elements into that particular hash set. But if it is the first time that we are trying to add that element, right, we create a new hash set and add it, right? That's what we are going to do as part of the insert operation. So all these could be done with order of 1 time complexity. So now let's move on to the removal operation. So if you understand the insert operation, right, so then it will build upon that insert operation. The removal is building on insert operation. So now remove. So we can remove only the value which is existing. So if the map contains this value, then only we will be able to proceed further. Otherwise, we are going to return false. So get the first one, whatever the index that we have, just get the first one. What we are trying to do is, if the end element is same as the element that we want to remove, we just simply remove the element at the end and decrement the end value, right? If it is same as the element that we want to remove, just in our first case we want to remove 4, right? We just remove 4 and decrement the end pointer. That's what we are doing. So we just remove and decrement the end pointer. But what if the element to be removed and the end is not same? We have to swap, right? We have to swap. So we are doing the swap operation here. Once we swap, we have to remove those corresponding indices from the map also. So here we are removing from the map. We are adding this new index into the map and we are removing the old index for the temporary value, and we were removing the map value also, right? So this is what we are doing when the map element to be removed is not same as the end element, right? So that's what we are doing here. After removal, if the count of that particular element becomes 0, right, just remove that corresponding entry in the hash table. That's what we are doing. So we are removing the value completely and finally returning the true, right? So the tricky thing is, if the element to be removed is not the last one, right? In that particular case, we are trying to swap and adjust the pointers in the map, right? So this is the remove operation. And get random, what we are doing is just get an element from start to n plus 1. Why I am doing n plus 1 is, in C#, the random value is inclusive of start but exclusive of end, but we want to include end also. That's the reason why n plus 1. So n plus 1 becomes exclusive, end will be inclusive, right? So that's the reason why I am using start to end, even though it is n plus 1. N plus 1 is exclusive, end is inclusive. So get whatever it is and return that particular random value. So this can be done in order of 1 also. So that's how we are able to solve the problem with 3 methods returning the values in order of 1 time, where duplicates are allowed. Again, I would like to remind you again, so please go through the problem 380 first. You can get the link from the description section of this video, the link for that problem, and then watch this. It will become much more clearer, right? So now let's go back to the time and space complexity. So initially we started saying, okay, all of these operations should be in order of 1 time, right? So we don't have to explicitly see, okay, how much time they are essentially taking. We can simply say that time is order of 1 for all of them, right? And space. So space complexity, we are going to look at the class level, not at the method level for each of them. So how much space we are using here? Space, we are using a map, we are using a list, and we are using start and end. So start and end, these are just 2 integer variables, so we don't need to worry about them. But the space that we are essentially doing are this one, right? The map and a list. So how many elements in the map in the worst case will be there, right? So the number of unique elements and their corresponding indices, right? So the space required for map will be this much, right? Number of unique elements. So in this particular case, 2, 3, 4 are unique, and corresponding indices. That means if there are n elements, right, you need order of 2n space, right? So order of 2n space for map plus list. How many elements we are storing in the list? All the elements, it doesn't matter, right? All the elements. So n elements, order of n. So how many total? It will be order of 3n. So the space required for this particular problem to solve will be order of 3n. So since we are going to remove all the constants from the big O notation, we will say order of n is the space complexity required for this, where n is the number of times we are called with insert operation, right? So there are some removal operations are also there, which we will compensate in the order of n anyway, but in the worst case it will be still holding order of n, right? So if you have any further questions, please post them in the comment section below this video. I will get back to you as soon as I can. I have posted this code to the GitHub repository. You can find the link in the description below this video. If you haven't subscribed to the channel yet, please go ahead and subscribe and share among your friends. Please click on the bell icon so that you will be notified about my future videos. Thank you for watching. I will be back with another problem very soon. Till then, stay safe and goodbye.